Example, the 20th percentile is the value or score below which 20% of the observations may be found. Usually, we report percentiles as below. The 25th percentile is called the first quartile. The 50th percentile is called the median or second quartile. The 75th percentile is called the third quartile. Range refers to the difference between the maximum and minimum data values. Interquartile range refers to the difference between the 25th and 75th percentiles. Variance refers to the data values around the mean value. Standard deviation is the square root of the variance, measured in the same units. It also indicates how spread out the data is. Histogram is a graphical representation of data distribution first introduced by Carl Pearson. To construct a histogram, the first step is to bin the range of values. That is, divide the entire range of values into a series of intervals, and then count how many values fall into each interval. The bins are usually specified as consecutive, non-overlapping intervals of a variable. The bins must be adjacent and are usually of equal size. In the graphical representation, each bar represents a group of values, also called bin. The height of the bar represents the frequency of the values in the bin. Histograms help assess the probability distribution of a given variable by depicting the frequencies of the observations occurring in a certain range of values. A normal distribution is the most commonly used distribution in statistics. It is characterized by its bell shape and its two parameters, mean and standard deviation. A bell curve or normal distribution, it's symmetric around the mean. If you draw a line at the center, you'll get the symmetric shapes on both sides. The mean, median, and mode of a normal distribution are equal. Normal distributions are denser in the center and less dense in the tails or sides. Normal distributions are defined by two parameters, the mean and the standard deviation. The bell curve is also known as the Gaussian curve. Let's understand the bell curve better. The bell curve is divided into three parts to understand the data distribution better. Peak. It's where most of the observations occur. Generally, the peak is within one standard deviation from the mean. Flanks. They are the areas beyond the peak, but between 1 and 2 standard deviations from the mean. Tails. They refer to the area far from the center of the distribution and considered to be beyond 2 standard deviations from the mean. Usually, 5% or less data falls under this. Skewed data distribution indicates that the tendency of data distribution is to be more spread out on one side than the other. In this graphical representation, the data is left skewed. Mean is less than median. The distribution is negatively skewed or represents negative statistics. Left tail contains large distributions. In this graphical representation, the data is right skewed or positively skewed distribution. Mean is greater than median. Right tail contains large distributions. Let's now learn about kurtosis, another popular measure of data distribution. In a similar way to the concept of skewness, kurtosis is a descriptor of the shape of a probability distribution, and just as there are for skewness, there are different ways of quantifying it for a theoretical distribution and corresponding ways of estimating it from a sample of a population. Depending on the particular measure of kurtosis that is used, there are various interpretations of kurtosis. Kurtosis measures the tendency of the data towards the center or towards the tail. Platykurtic is negative statistics or negative kurtosis. Mesokurtic represents a normal distribution curve. Leptokurtic is positive statistics or positive kurtosis. Hypothesis testing is an inferential statistical technique to determine whether a certain condition is true for the entire population. For example, in a manufacturing company, the hypothesis is that every dress manufactured has no defect. A study of each dress manufactured and noting the defects as they occur will prove or disprove the hypothesis that every dress is flawless. A hypothesis test studies two opposing hypotheses about a population, the null hypothesis and the alternative hypothesis. The null hypothesis is the statement that has to be tested. Usually, the null hypothesis is a statement of no effect or no difference. The alternative hypothesis is the statement that has to be concluded as true. To quickly summarize, alternative hypothesis. It's a research hypothesis. It needs a significant level of evidence to support the initial hypothesis or assumption. If the alternative hypothesis garners strong evidence, reject the null hypothesis. Null hypothesis, it's the logical opposite of the alternative hypothesis. It indicates that the alternative hypothesis is incorrect. Weak evidence of alternative hypothesis indicates that the null hypothesis cannot be rejected. The table explains how a decision can be made based upon the hypothesis testing. Type 1 error rejects the null hypothesis when it is true. The probability of making type 1 error is represented by alpha. Type 2 error fails to reject the null hypothesis when it is false. The probability of making type 2 error is represented by beta. Probability value. The probability of observing extreme values or more extreme than the one observed. Calculated from collected data. Let's understand the process of hypothesis testing. The first step is to set the hypothesis. The hypothesis could be null or alternative. The null hypothesis, or H0, states that a population parameter is equal to a value. The alternative hypothesis, or H1, states that the population parameter is different than the value of the population parameter in the null hypothesis. The alternative hypothesis is what is believed to be true or is to be proven true. The next step is to set alpha, or choose the significant level for the population. The third step is to collect the sample from the population, which represents the characteristics of the population. The final step is to compare the p-value and alpha. You reject the null hypothesis if p-value is less than alpha, and fail to reject the null hypothesis if p-value is greater than or equal to alpha. This example shows how clinical trials can be analyzed. Suppose a pharmaceutical company wants to compare a medicine it manufactures with that of a competitor's medicine. Then, hypothesis testing can be the method it adopts. The null hypothesis would be that both the medicines are equally effective. The alternative hypothesis would be that the two medicines are not equally effective. There are three types of data on which you can perform hypothesis testing. Continuous data. Evaluate the mean, median, standard deviation, or variance. If you take the same example to test the efficacy of medicine, take the temperature of every person in the sample after 3 hours of administering the medicine. This would be referred to as continuous data. Binomial data. Evaluate the percentage general classification of data. When data is divided into two categories, you obtain binomial data. Supposing the same population